Hi, I'm Jessica Henn in Bio 100 Team Charmander Section 10. I'm here to answer questions 26 and 27 from Exam 3 study questions. Question 26. Assume that being right or left-handed is determined by a single gene with two alleles and that right-handed, big R, is dominant to left-handed, little r. An in-class CPS exercise determines that 50 students in a class are left-handed out of 250 students. What is the frequency of homozygous recessive individuals? Okay. Okay. So 50 divided by 250 equals 0.2. Therefore, 20% of students in the class are left-handed. So we have big R, big R, big R, little r, little r, little r. 50 students out of a total of 250. So 0.2%, which is 20%, are left-handed. Now, according to the Hardy Weinburg equation, P plus Q equals 1, P squared plus 2PQ plus Q squared equals 1, where P squared is the frequency of homozygous dominant, 2PQ is the frequency of heterozygous, and Q squared equals the frequency of homozygous recessive. So we now know our Q squared. So Q squared equals 0.2. Now to find out what Q is, all we have to do is the square root of 0.2, which is approximately 0.45. I've rounded that. So now we know Q squared equals 0.45. So P plus 0.45 equals 1. So minus 0.45 minus 0.45, P equals 0.55, which we'll then write over here. Okay. Did I write Q? Oh, this is not Q squared. This is actually Q. Sorry. Q squared equals 0.2. Okay. Okay, so now we know P and Q, and we know Q squared, and now we can get P squared easily enough by squaring that, which will give us our P squared, which is 0.3025. Okay, so now we can go over here, say P squared equals 0.3025. Now we just need to figure out 2PQ. So 2 times see here, 5 times Q is actually 0.45, and that, I've already done the math, equals 0.495. So 2PQ equals 0.495. Now, over here we've already said that P squared is the frequency of big R. So we know our frequency over here is 0.3025. And 2PQ is the frequency of big R, little r. So 2PQ frequency is 0.495. Easily enough. Yay. Okay. Now the whole question, for question 27, was assume that the Hardy Weinburg equilibrium conditions are true for this genetic trait right or left-handedness. What is the frequency of recessive little r allele in the class? What is the frequency of dominant big R allele? What is the frequency of heterozygous genotype? So frequency of heterozygous genotype is 0.495. Now I wasn't quite sure how to interpret frequency of recessive little r, frequency of dominant big R. So I just assumed that what you meant was how many big R's and how many little r's are there. So there are 250 people in the class who can each have two, what is that? Alleles, thank you. So, then 2 times 250 equals 500. So then I went through And, okay, there's 50 people, little r. Clearly, there's 100 little r's here. I just did the math, 500 times both of these numbers. So we found out that there are 151.25 big R's in here, which is kind of silly, but okay. And over here, we have 247.5 big R's, and same for little r's. So then I was dumb and did not do the math of adding all these up before I started this video. So give me a second to actually do math on camera. Okay, so we have 100 little r's plus the 247.5 little r's over here. So that is 0.5, so 347. Okay, that is how many little r's there are. And then big r's, I will just erase the Hardy Weinburg equation over here, because we already know it, and we already solved for that. Okay, so big R, we have 151.25 plus 247.5. Okay, so this is 0.75. And now I reveal how really bad at math I am and pull out my calculator. 151. No, I don't even do that because I already did that. Okay, plus 247 equals 398.75 big R's in this classroom. And there you have it. Thank you. This was Jessica Henn.